Alright, so in this video we're going to be going over Dirac delta functions. They sound complicated, but I assure you they're not all that hard. Basically, in the beginning here we're going to be given one of two forms. We're going to be given the integral from negative infinity to infinity of f of t Dirac delta d of t. And all this means is we need to plug in 0 for t, and that will be our answer. Now the second form we'll be given is the integral from negative infinity to infinity f of t Dirac delta t minus a dt. And in that case we just need to plug in a. Okay, so let's do a example here. So on number 31, this should be pretty similar to your number 31. We're given a Dirac delta function with t plus 2. So it's in this form, but we need to realize that it's t plus 2, not t minus 2. So we need to change it into t minus 2. So I'm just going to do this here. So t minus negative 2 dt. And then all the regular stuff just stays the same. So we have the integral from negative infinity to infinity, 6e to the negative 4t. Sorry, it's a little tight. But as you see, there we go. This is the same function as this, just rearranged so it's in this form. And we find that a is equal to negative 2. So we just plug in a for this, or for t, because this is our f of t. And then we get 6e to the negative 2 times negative 4 is 8. That's our answer. Not all that bad. Similar for this one, but in this function, this is the same as number 32 on the homework. We're given the first form, where there is no plus or minus a in this Dirac delta function. So we just put f of 0. So we plug in 0 for t, we get the cosine of 0 is 1. 9 times 1, 9. That's how you do the first two for 7.9. So like most things in this chapter, we can take the Laplace transform of it. So in this case, number 33 and number 34, we're going to find the Laplace transform of a Dirac delta function. And like the last section, or the last part of this video, it's not all that hard. Basically, all we need to do is identify a, and then do the same procedure as we did in the last part, then add e to the negative as. So you'll see here, we have, it's in that form t minus 3, so a is equal to 3. So here we have 3 cubed, which is 27 times 2, 54. So 54. Now we just have to add, or multiply e to the negative as there. So e to the negative 3s. So that's it. That's the Laplace transform of number 33. Let's go to number 34. A here is 2. So we have 3e to the 8 times e to the negative as. That is e to the negative 2s. That's the Laplace transform of the Dirac delta.